Okay, Assalamualaikum and good morning to everyone. Can you hear me well?
Yes, madam.
Okay. So today is we are now in week 12, right? Week 12. We have 2 more weeks for the semester to end, right? Am I right? So we have like 2 more topics to cover, and then we have 2 more assignments to do, and 1 quiz to do, right? And also your PBL3 submission. Okay, so still got a lot of work to do within these 3 weeks. So we will have to do one at a time. So beginning today, we are going to finish off topic for week 13, which is verification. Right, so we will do that today. And also I want to talk about a bit on PBL3, which the submission due is supposed to be on this Thursday, right? So I want to talk about that, and also to tell you that we will have a quiz, quiz 3, the final quiz, which also I have scheduled it to on Thursday, 7th January. So we will talk about the PBL first, and then we go to talk a bit on the quiz, and also lastly we will do the class, right? So for PBL3, in your UUM online learning, we have our folder materials for PBL3. So in this folder, there are some documents that I have uploaded. Okay, I think I forgot to save it. Yesterday I uploaded 2 documents. I will upload it later. I will just show you now so that you can see some examples, because a lot of students were contacting me through UUM online learning to ask about about the PBL3 assignments, how to develop the interface and so on. So I'm going to show you examples of previous students. Okay, it's a PDF file. Let me share it. Okay, so this is an example of assignment for group, one of the group from previous semesters. It's just a simple system of vehicle sticker online system, right? For report part, for the interface design, you still have to use the same template that you have been using for PBL1 and PBL2, right? So use the same template, prepare a cover page like this, right? And then you have to put in the interface. For example, if you have a login interface, login function. So what is the interface for login, right? Then I need to see the input design, the output design and navigation design, right? So you have to have all the things that we have discussed about interface design. So for each function, you should have an interface. It also have to match with your sequence diagram, because in your sequence diagram you have already mentioned that how many interface object you have, right? You said that you have panel, right? Login panel, then you have main menu and so on. So you have to follow that, right? Because you have to make sure whatever interface you design must have must tally with the sequence diagram, right? So this is examples of drop-down menu that are used by the students for their interface design. So wherever you can apply all those input types, right? Types of input like drop-down, slider, box, radio button, and so on. You have to use them, right? Especially for your forms. So whichever that student can select, you have to make it easy for them to select without typing, right? So this one is an example of forms which are already being filled up, right? Then it goes on. What are the other processes that are involved? So you have to put in all the. So you can use any software for developing your interface. Doesn't matter, because we are not going to develop a prototype that is working, right? So we are just for system analysis and design class, we want to see your design that matches the models, the UML models, right? So interface design must match your UML models. That's the point. So you can use any software, but make sure that the software that you are going to use have all the input items like drop down, right? Menus, radio buttons, and all the input. If you use something that you have to develop from scratch, it will be big time consuming. So you have to find software that already have this kind of where you can just use it, right? So this is one example. I have another example for you. Second one. Okay, this one. This one is also report for PBL3. So this is the main interface for their system, employee self-service salary checking system, right? So it's more like a web, eating a web system. So it has like a web interface. So all the buttons are there for each of the functions in their. So here the students, the group have given some instructions or some descriptions about what are the buttons that are available on the screen, and so on. So, and they follow the placement of the interface according to the use case. So for the use case login, right, and they give the number of according to the functional requirement. And then what the user has to do, right? And also this is the exceptional flow of which you have designed. If you have an exceptional flow that checking about valid username and password and so on, you have to put in what are the interface that you should design to show exceptional flow, like invalid username, password, right? So here the students mention that this is an exceptional flow of invalid username and password. which numbers E011. So this one is very detailed, right? And what are the other functions that you have? Calculate salary, manage salary. So for calculate salary, this is the screen. For manage salary, and even for the calculate salary, you have the invalid ID, employee ID, which is the exception flow. And if successful, key in what happened, what are the messages that the system shows. And these are examples of alternative flow. So this one is very detailed, but because they have a lot of functions, right? So if you have any questions, you can ask now. Any questions? Any apps that has all these input designs, drop down menu, radio buttons, where you can use them. Or if you use app that or software that doesn't provide that, it will be difficult for you to design, right? So it's better to use that has all the input navigations and output items. You can use any software. No, your system does not have to have a database. So this is not a database class, and we want to test you on how you design your UML model and how does it suit or match with your interface. If you want to put in database, it's up to you, right? But doesn't necessarily have to have a database. Any other question? Okay, so if you have any other questions, maybe you can ask me later. Right, so let's go to the next thing that I want to discuss. The next thing is about our quiz, right? Quiz will be carried out tomorrow. Next class, which is on Thursday. Okay. For the PBL3, I want to see some of your designs before you submit. So for that reason, plus for the presentation, you have to prepare. I have decided that for the presentation, it's better for you to prepare the videos, right? Because if we want to do like face-to-face presentation on WebEx, for example, it will take time because I need to see all the groups present and all the members presenting. I give marks for each, so it will take time. So what I have decided, the presentation also you have to prepare videos of presentation as you have done for PBL1 and PBL2. So the contents, okay. For PBL3 is actually a combination of all your PBL, right? Even in your report, when you submit, you should not just submit the interface. You have to combine back all the PBL1. That means you have to put in the functional requirements, non-functional requirements, and then the diagrams use case diagram and activity diagram, then the descriptions. That is PBL1 things, right? Then you continue on the same report. You combine, right, together with the sequence diagram, the communication diagram, and the class diagram, right? And then after that, you go on to the interface design, and you can put in as I show you the example, right? So you have to combine all to become one report. Okay. Even for your presentation, you also have to do the presentation from the beginning, right? But you don't have to go in detail. You can just like discuss only the main functions. You show me the use case diagram, the activity diagram, but you don't have to go through the descriptions. You can move on to the one of the sequence diagrams, some, right? Not all. And you have to be clever on which one you want to show. And after that, the main thing is the interface. That interface you have to have you give some more time for the interface design to be presented for PBL3. So I hope that is clear. So for that, I'm going to extend the due date for submission of PBL3 to week 13, right? We're supposed to submit week 12, which is this Thursday. But this Thursday, I'm going to have a class on Thursday before we do the quiz to check, right? Some of your interface, right? Like to see whether if I can give some comments that can help you, right? So maybe you have done something and you want to show me, you want to ask me whether this is okay or not. So this is the chance, right? Before submission. So we will do Thursday, like 1 hour like that, just to check the interface, and then the next hour would be for the quiz. Right? Quiz 3 is about only week 12 topic, right? Interface design topic about navigation, input, output. There are a lot of things that we'll discuss, theoretical things. So try to read only that topic, right? And be prepared for a short quiz. It might only take around 15 minutes like that. Very few questions, maybe just like multiple choice or maybe true and false short answers for quiz 3, which we will start at 9:30 a.m. and the quiz will be closed 10:30 a.m. But time limit that I give you is 30 minutes to complete. So whenever you start, the time will count down 30 minutes, and only one attempt is allowed, right? So it will start on Thursday, 9:30 a.m. So before 9:30, 8:30 to 9:30, maybe we can just have a look at your interface, right? So that is planned for Thursday. Okay, so any question on that, on quiz or anything? If you have, you can just type in. I will check it later. So now we have to cover topic verification. So I'm going to share the PowerPoint slides that we are going to use for this class. Okay, so this is actually week 13's topic, but as you know, we are ahead 1 week. So we have finished our topic 12 last week, the interface design. No, actually we have done interface design earlier than that, week 11, and we have shifted the state chart diagram for week 12. Okay, talking about state chart diagram, I remember that I have given you an exercise 2, which there's a question on exercise 2. So that answers I will put in on the online learning later. right? Just the answers for exercise 2 for you to check whether it's correct or not. So today we are going to do week 13 topic, verification and system risk analysis. So in this topic, what we are going to learn is about design refinement concepts, right? So I'm going to explain to you what is actually design refinement, right? And then we want to talk about the basic of design evaluation, like how to evaluate a design, whether to say that, oh, this is a good design or this is a bad design, right? So what are the good design criteria? Okay, so we want to talk about that. And then there is some concept in design about decomposition of a big system into a smaller system, and then concept of cohesion and coupling, right? So we want to explain that and to show you examples. Then there are two other learning objectives that is about identifying risks in design and also how to apply best practices in design. So most of the things that I'm going to discuss now today would be more like a theoretical concepts and which you can apply in your future undertakings of designing systems, right? So let's start. So design refinement, what actually we mean by design refinement is when we design a system, some of or a lot of people who are involved in developing a system, they tend to move immediately to full detail, right? And like for example, once you have finished coming up with the UML models, you skip the design refinement step and you go directly to the implementation, which you go directly to coding and so on. So that is actually is not a good way, right? You have to spend a lot of time after you come up with a UML model to go back and do refinement, right? So this will, if you skip this refinement step, this will lead to errors and omissions, and design would be much more difficult to review. So therefore, refinement should be performed, right? So what is actually refinement? Refinement is a process of elaborating, right? Elaboration. So like detailing out. So we begin with a statement of function. Like when we start our PBL, for example, right? For the project that you have been doing for your system, you start out by just defining some of the functions, right? The functional requirements, the non-functional requirements, and then you move on to the description of those function with the use cases and so on. So at that one, we call it a high level of abstraction, right? So this is actually the high level of abstraction is actually just a statement that describes function or information conceptually, but provides no information about the internal working of the function or the internal structure of the information. As you go on to PBL2, you become more detailed, right? So when you go to PBL2, when you design the sequence diagram, you have made more information. You got more information, and you have made your PBL1 more detailed. The use case spec also, at first you were just putting in the basic flow as a high level of abstraction, like what you perceive it to be, you wrote it, and then when you go to sequence diagram, you found out that you have to go back to your basic flow and improve it, right? So as you go on through the UML steps, you will find that you are actually doing the refinement, right? So to give you an example, for example, if when you, let's say, just a small task, you want to open the room door, right? So at the beginning, when you want to describe how to open the door, so you will say, just you will write down in the UML functional requirements, just you say open door, right? But as you go on to the sequence diagram, for example, you have to be more detailed about how to open the door. So you walk to the door, you say, okay, you walk to the door, you reach the knob, right? And then you turn the knob to open the door. So that is one step detail about how to open a door. So as you go on to design refinement, you go back to that and you refine whatever details that you can put in. So for example, for the opening of the door, you have already explained walk to the door, reach the knob and turn and open the door. But you can go on more detail. You can say that, okay, repeat this until the door opens. Turn the door clockwise. If knob doesn't want to turn, then insert the key in the lock, right? Then push the door open. So it's like you are detailing out as much detail as possible. So that is actually refinement of your design. So refinement causes the designer to elaborate on the original statement, providing more and more detail as each successive refinement or elaboration occurs. So what actually you are doing is you are actually helping the designer to reveal low-level details as the design progresses, right? So you are not just describing high-level abstraction. Now you are going low-level so that this detail can help the programmers to program your system very well, right? So this concept aids the designer in creating a complete design model as the design evolves. So what are the design evaluation? When we talk about learning objective number 2, we talk about how to know that you have designed a good system, right? So there are some criteria. So these criteria are categorized into a few categories. So the quality of the design will clearly be reflected in the quality of the finished system that is delivered to the clients, right? So the system itself, what are the characteristics that it must have? So that's what we are going to discuss now. So first, you must ensure that the system that you have is able to function, right? System must be able to function correctly and completely. So that is very important. So it must perform all the functions that it is required to perform, right? So if you have identified that your system has these 6 functional requirements, so make sure all the 6 functional requirements are met, right? So it's able to do all of it correctly and completely. So that is one, able to function. Next is your system must be efficient. Efficient in terms of what? In terms of using, in terms of time, right? It should not take too long. So this is more towards the non-functional requirements. The time that it takes to process, the resource usage, the storage, the data processing time, and network capacity, right? So these are the things that measures the efficiency of a system. So in these things, you also a system will be evaluated on the efficiency. Next is economical. The development and the operating cost must be minimum, right? So it shouldn't be unnecessarily high cost to run the system, right? So if it's incurs high cost, then it's not a good design. Others are reliability in terms of the hardware and the software component of the system must be reliable and function as expected. So it does not prone to hardware or software failure, right? So if it fails in the middle of operation, that means it's not reliable. So that is reliability. Next thing is security. Design must include system security features such as restricting user access and so on. So these are to protect against errors, against attacks, right? To safeguard the data, right? So to ensure the data are not lost or being accessed by someone else. So those are all security that you have to consider for your design of the system. Next is flexibility. So system must be able to be expanded to adapt the requirements, changes, and technology advancements. So at some point, there must be some changes that happens outside or in the organization itself or the environment or the country itself. So your system must be flexible enough to expand, to change accordingly, right? Not big changes like big functional changes, all right? But small changes are need to be considered, and your system must be flexible to adapt that. Some more of the criteria about portability or reuse. System must be able to function in any platform and can be used by any other organization without major changes. So it should be able to run. So if you have designed it in mobile app, all right, it can also be run on web pages, on PC and so on. So those are portability, right? Different platforms, different operating systems, right? Maybe it can work on Android and on iOS. So those are all this. Next is can be developed, buildable. So this is also a very important criteria. If you design a system which is too complex, for the programmer to program it, so it's not good, right? So design must be clear. It's not too complex and easy to be developed, right? So this is from the programmer's perspective. If it must be not too complex and not too simple as to don't meet all the requirements. So you have to meet all the requirements, but at the same time not too complex. Next thing is the manageable. Manageable is about how the project manager must estimate the time and resources needed to develop the system. So to estimate work also, right? And how much the work has been done to check the progress. So it must be manageable, right? That's very important also for a good design. The other things are about easy to maintain, right? So your system should be able to be maintained because 60% of computer department budget are to be used to maintain system. So maintenance, we have a topic, last topic we will talk about maintenance, what are involved and so on. So these include like correcting bugs, changes in reports or screens, system upgrades to cater for changes in the requirements. So all these are considered as maintenance, right? So should be easy to do that. Usable, the system should both satisfying and productive. This is on the user's perspective, right? Before we saw the programmer's perspective, but now for the user's perspective, the system should be easy to use and reusable. Designs that take into consideration the concept of classes and inheritance will produce reusable components that can be used by other systems. So then you have it, all the criteria. So far we have discussed 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. These are the 12 criteria for good design, right? So that covers the learning objective number 2, to elaborate and apply a basis for design evaluation and good design criteria. Any questions so far on the slides or anything? Okay, now we will move on to learning objective number 3 to talk about the concept of decomposition, concept of coupling and cohesion, right? Okay, what is a decomposition? So this is also considered a good design when you have when you know how to break down a system into smaller components or smaller subsystems, or sometimes we call it terminal units, right? So that's what decomposition means, right? Breaking down a system into smaller constituents. So the subsystems are themselves systems and can be broken down recursively until only terminal units remain, right? So what is a terminal unit? Terminal unit is an irreducible part, a piece that cannot or need not be broken down further. So it's like you want to develop a huge system, right? Or maybe it's not that big system, but you still have to know how to decompose your system into smaller units. The reason why we need to know this, because if we have any problems, then we can just tackle that small unit. We don't need to go through the whole system and repair the whole system, right? So that's the reason. For example, a CD system decomposed into 4 subsystems. So the 4 subsystem first is the signal reading subsystem, signal amplifying subsystem, signal control subsystem, or signal conversion subsystem. So this is one example of how you decompose, right, a big system into smaller subsystems. So the decomposing of a system allows us to focus on one particular part of a system, making it easier to think of how to modify that part independently, right, without affecting the others, right? So independently of the entire system, and enhances our understanding of how the overall system works. So that is the ultimate goal of why we want to decompose a system into smaller subsystems. Okay, next concept is coupling and cohesion, right? So this is proposed by Jordan and Konstantin. They define that a series of criteria that could be used in breaking system into modules is coupling and cohesion. This is to ensure that they are easy to develop and maintain, right? So the issue is coupling and cohesion. So we look at coupling first. So what actually coupling is? Coupling actually refers to the strength of dependencies between 2 subsystems or classes. So if you have already decomposed your system into 4 subsystems, for example, you have to see whether this subsystem can work independently or it depends on another subsystem. For example, the output of one subsystem becomes the input to the next subsystem, right? If there is some dependency, so you have to think about how much is the dependency, right? So you have to describe the degree of interconnectedness, right? Degree of interconnectedness between those subsystems. So it refers to how independent or interrelated the modules are. So these can be classes, the interdependency between classes, the interdependency between objects or methods, right? So it is reflected by the number of links an object has and by the degree of interaction the object has with other objects. So our aim is to make the coupling very low. We don't want too much interconnectedness, right? So low coupling is results in subsystems that can be modified with minimal impact on other subsystems. So here is an example of coupling. So if you have a system that is broken down into 4 subsystems like this, for example, if there is no relationship or interconnectedness between the subsystem, then we say these subsystems or this system has no coupling, right? No coupling. But if you have some interconnectedness between the subsystem like this, right? This one depends on this one, and this one depends on this one depends back on this one. So there is some interconnectedness. We say that this is loose coupling, right? But if you have a lot of interrelatedness and a lot of functions need to depend on other subsystem, so this one is an example of high coupling. So which one is good? Of course, no coupling is the best, but sometimes we need interconnectedness because some function need to wait for another function to finish. So then loose coupling is also a good, but high coupling should be avoided, right? So we don't want to have a system that with high coupling. So if it's high coupling, it's not a good design. Is that clear? Hope you understand the concept of coupling. I have tried my best to explain the coupling concept, right? So you want to make sure your coupling should be low, right? Not too high like this. Next concept is cohesion. So what is cohesion? Cohesion refers to the strength of dependency within subsystem or a class. So just now was in between subsystem, but within subsystem, inside the subsystem itself, there are some components that need to be, linked, the interconnected components. So this one is within the subsystem or a class, not in between 2 subsystems or 4 subsystems. So cohesion is a measure of the degree to which an element contributes to a single purpose, right? The degree to which an element contributes to a single purpose. So you cannot have one class that is used for 2 reasons, right? 2 purposes. It must have one class for one purpose, one subsystem for one purpose. So cohesion refers to how single-minded a module is. So this module can be class, can be object, can be method, right? Within the subsystem or within the system. So for this cohesion, we need to make sure we have a high cohesion, meaning that you have to make sure that you are very single-minded, right? So high cohesion is desirable as it keeps related classes together so they can be modified consistently. So both this concept of coupling and cohesion are not mutually exclusive, but actually support each other, right? So you have coupling is not is between subsystem. Cohesion is within one subsystem. So they actually support each other. Cott and Jordan suggested several ways in which coupling and cohesion can be applied within an object-oriented approach. So we are going to look at those several ways that are suggested by Ford and Roden. Time is it? 9:30. Okay. So we want to look at couplings type first, right? So remember when we say coupling, that means it is between two or more subsystems or classes, right? When we say cohesion, is within one subsystem or classes. So interaction coupling, these are the type of coupling. We have three actually: interaction coupling, inheritance coupling, and two types of coupling. And for cohesion, we have three types of cohesion. Okay, so we are going to discuss each one of these. So try to understand, and if you have any question, you can ask me, because it's a bit difficult actually to focus and understand this concept. Okay, we look at interaction coupling. This type of coupling, which we call interaction coupling, is a measure of the number of message type and an object sends to other objects, right? The number of message types. So how many messages are sent from one object to another object. And it also measures the number of parameters passed, right, with these message types. So there are two things that the number of messages and also the number of parameters. Okay. So interaction coupling deals with the coupling among methods and object through message passing. So it should be kept to a minimum to reduce the possibility of changes rippling through the interface and to make reuse easier, right? So if you have two objects, so how many messages are sent to each other, right? So you can look at this in your sequence diagram, because you have drawn the sequence diagram and you have drawn the messages that are passed between the objects, right? So check back if you have a lot of messages that are sent from one object to another object and a lot of message passing, then you might have a high coupling, right? So you have to keep it at the minimum, right, to reduce the possibility of changes. The second type is inheritance coupling. So it deals with how tightly coupled the classes are in the inheritance hierarchy. So here in this example, we have two classes, right? We have vehicle and land vehicle, and land vehicle is the subclass of the superclass vehicle. So land vehicle is inheriting the attributes and the operations from the vehicle, right? So here we say that this is a poor inheritance coupling. Why? Because land vehicle do not need these two variables, these two attributes. Does land vehicle have altitude or takeoff speed? These two attributes are not suitable for land vehicle because they are more to air vehicle, right? For the planes. So planes have altitude and takeoff speed. Check altitude and takeoff. So all these operations also are not suitable to be inherited by the land vehicle. So even if the land vehicle inherited it, it will just make the land vehicle more complex of a class. So that's why we say this poor inheritance coupling. So what should we do here? How to correct this design? So this design is not a good design, right? So in order to correct it, so you have to remove attributes like altitude, maximum altitude, takeoff speed, check altitude, and takeoff. You have to remove these two attributes and two operations from here, and you have to put that in another object called, maybe you can create an object called air vehicle, and you can put those attributes and those operations there, so that the land vehicle will only inherit attributes that are used by it, that wanted by the land vehicle. For example, descriptions and service date are needed by all vehicles, right? So if you put one more arrow here, right, and you create one more object, land vehicle. So let me see whether I can annotate it. Okay. So here you have to create another arrow. Okay, so before that, it's not working. I have to buy a annotation pen. Okay. So what I meant is we have to delete that. Oh, like this. So what I meant that we have to create another object for here as for the air vehicle, and you have to put in all the attributes and operations that are needed here. So you have to move all this to this part. Then only you will make sure that your design is a very good design that has low coupling, right? Low inheritance coupling. If not, it will be a bad design or not good design. Okay, so that is about coupling. Let's go on to the type of cohesion, right? So cohesion, as you remember, this is about one class itself or one component itself inside one component. So it's not between two components or two classes. Coupling, yes, it is between two classes. Just now we saw vehicle and land vehicle, right? So now cohesion is between a single class, right? So we look at operation cohesion. It measures the degree or to which an operation focuses on a single functional requirements. All right. Let's look at example first. So actually operation cohesion and class cohesion will be discussed together. So let's look at, we will give example together. This class cohesion reflects the degree to which a class is focused on a single requirements. A class should only represent one thing, right? So good design produces highly cohesive operations and classes. So let's look at example. Okay, so here we have an example of cohesion for operation cohesion and also class cohesion. So we have a class called a lecturer. So within this class, we have attributes and operations, right? So for a lecturer, you need attributes like lecturer name, lecturer address, room number, room length, room width. And the operation is calculate room space. So here we say that these examples have a good operation cohesion, but poor class cohesion. Can anyone tell me why? Why is it why they say that it has good operation cohesion? Any answers? I hope I'm not talking alone here. Anybody want to try to answer why this one is say good operation cohesion? The class is well explained. The good operation is because the written part. Not quite right what you answered. Okay. The reason why it says a good operation is because for the operation calculate room space, right? So the operation already have all the necessary attributes that it needs, right, in order to calculate room space. So you know that to calculate a room space, you need the room length, you need the room width, right? So you can calculate the square foot of the room by just multiplying room length with the room width. So we say that this operation is a good operation cohesion because all the attributes that it needs, it doesn't have to go to ask that operation from other class. It's within its own class, it has all the attributes that it needs, right? To get it, calculate room space. If you go to the detail of the calculate room space operation, it needs this parameter room length and room width, right? So these two parameters are within the class. It doesn't need to go to elsewhere to find it. So it is here. So we say that it's a good operation cohesion. So that is clear, right? Good operation cohesion. Is it clear? Yes, no? Okay. So now we go to the poor class cohesion. Why it says poor class cohesion? The class name is lecturer, right? So do we need to put in attributes like room length and room width for the lecturer class? So that's the question, right? So if you look at these attributes, which attributes that are suitable for the lecturer and which attributes can be put in elsewhere, another class, for example? Lecturer subject. Lecturer subject is not here. I'm asking from the attributes that we have. Okay, so someone said the lecturer attributes remains in the lecturer class. Which one is the lecturer attributes? So, of course, name and address, right? Name and address is suitable to be left in the lecturer class. But room number, room length, and room width can be taken out. Yes, the room attributes can be separated. You can put into another class, right? So it's like you can put in, like you can create another class here, for example, right? You can put in here. Here is the room. Maybe it's a room class, right? So all you can move all this, okay, including the operation. You can move it to this room. This room class, so that the lecturer has only the attributes that are suitable to be in the lecturer class. So if you do that, then your design would be a better class cohesion. Okay. So operation cohesion is good because operation will still have the room number, room length, and room width because you will move together with the calculate room space to the new class. So I hope that one is clear. Now we go to the specialization cohesion, so inheritance and so on. So here we have an example which shows you we have classes, address, person and company, and person and company inherit address. So is this a good specialization cohesion? The answer is, of course, no, because it says poor, right? So this is an example of a poor specialization cohesion. So why is it said poor specialization cohesion? Can anyone tell me? So when we use inheritance, when we have a subclass that inherits something from the superclass, right? And this subclass and the superclass usually must be the same kind, right? So there are some answers here. Both person, company do not inherit the attributes from class address. But they have address. Don't person and company all have address? Actually, the answers that you give is slightly correct, but the way that you put it is not that correct. Both person, company do not inherit the attributes from class address. Person must be what? Superclass. So if persons to be superclass, then address would be subclass and company would be subclass. Okay, let me ask you this question. Is the person a kind of address? Or is the company a kind of address? So usually when we put in inheritance, we say that, okay, for example, like the vehicle, land vehicle is a type of vehicle, right? So that's why we put it as inheriting from the vehicle class. But in this case, is a person a type of address? Or is a company a type of address? So that's what it means when we put the inheritance here. It means that we are saying that this subclass is a type of this superclass. And this subclass is a type of this superclass. That's what it means, right? But in this case, a person is not an address. A company is also not an address. But they need these attributes, right? They need these attributes. So how to improve that? So this is a poor specialization cohesion. So how to address that? Is to remove the inheritance and put a normal association, right, between the person and the company. So when we put the normal association, so then we can use all these attributes for person and we can also use all these attributes for company without saying that person is a kind of address and company is a kind of address, right? So that is poor specialization cohesion. So So it's all about inheritance. So did you understand that? Okay, so let's move on. We just have a few more slides to go, just to talk about the last two learning outcome about risk in design and also further design guidelines, right? So what are the risks in design? So there are a few things that are considered risk, especially when you're designing associations. So it is important to analyze the message passing between the objects tied by the link when deciding to implement an association. So because when you do too much association, then it becomes a risk, right? So you have to make sure that the associations are designed well. You have to think about whether we really need that association or not. Right. So the next thing is integrity constraints. So to ensure that the application holds data that is mutually consistent and manipulates it correctly. Right. So so that is about how well your data is used. Right. How well is protected. And also there are various forms of integrity constraint. For example, like referential integrity, to ensure that an object identifier is an object in an object is actually referring to an object that exists, right? So that is referential. So integrity in terms of referring to another object, right? So that is referential integrity. Dependency constraints. These are to ensure that attribute dependencies, where one attribute may be calculated from other attributes from different classes, are maintained consistently. So, for example, like that room calculation about room width, room length. In case you need to calculate and you need some information from other classes, so that dependency constraint must be must pose a risk, right, in your design. But some cases we need that kind of dependency just to make sure that you focus on those things when you do some modification in your system. Because sometimes we will see that people do modification in one part, but they didn't notice that this part has affected the other parts. So that would be a risk, right? Domain integrity is to ensure that attributes only hold permissible values, right? And those are about integrity constraints, and the other risk is about designing operations. So here to determine the best algorithm to perform the required functions, factors to consider in designing algorithms include the cost of implementation, performance constraints, requirements for accuracy, and then the capabilities of the implementation platform. So all these need to be considered. Okay, so the last learning outcome is about further design guidelines. So there are a few, like for example, design clarity. A design should be made easy to understand as possible, right? So that not only the design is understood by the user, but it's also understood by the programmer when they want to develop the system. Don't over design, all right? So that is also because developers, they are tempted to satisfy a wide range of future requirements. So requirements that are not actually asked by the users, but they feel like it might be needed for the future. So they tend to design that. But this will cause the programmers to suffer because of all those future requirements that might not be needed by the user, right? So you have to make sure you don't over design. Then control inheritance hierarchies. inheritance hierarchy should be too deep, not too deep, right? So that it would be too difficult to understand or too shallow. So if you need inheritance, so you have to put in the inheritance, but make sure it is not too deep until you have 3 levels of or more than. So actually it depends on how many levels, depends on how big your system is. Some people suggest that up to 9 levels are manageable, right, according to Jordan. Some researchers like Rumbach, they say that about 4 or 5 levels is already too many. So which one, right? So it's very subjective. It depends on the complexity of the system. So you have to make sure if you don't need too much detail, too much deep, so don't go too deep, right, in the inheritance hierarchies. Keep messages and operations simple. Try to limit the number of parameters passed in the message to no more than 3, right? Not like 4 or 5 parameters that are needed, that would be too much. And also operation specification no more than 1 page. This is to describe the operation. Design volatility is about a good design will be stable in response to changes in the requirements. So even if there are changes, your design can adapt to it, right? So if you have use encapsulation, so that can help. That will be a key factor to produce a stable system. And then evaluation. When you want to evaluate your system, you can evaluate by scenario. An effective way of testing the suitability of a design is to role play it against the use cases. Design by delegation also can improve reusability. A complex object should be decomposed, if possible, into component objects, forming a compositions or aggregation. Then behavior can then be delegated to the component objects. And keep classes separate. Do not place one class inside another, right? So in like the lecturer and room, we saw just now, the lecturer and the room class is inside the lecturer class. So that will create poor class cohesion. So internal class is encapsulated by other classes. The internal class cannot be accessed independently. So this reduces flexibility, right? So there you have it. The last design guideline for you. So that's the end of the slide. So if you have any question, you can ask. Anything to ask? Okay, can. Let me share the attendance. Okay, so if you don't have any questions, then I will meet you on Thursday. Thursday, the first hour, we will check. I want to see your interface. I'm sure you have designed your interface for your system. So I want to see the interfaces because the submission would be the following week, right? For week 13. As usual, you have to prepare a report, a presentation, and also peer evaluation forms need to be filled, which I will create the links as soon as possible on the week 13. And And don't forget to read chapter on interface design for the quiz. So just a simple quiz for quiz 3 on topic interface design. So that's it. I will see you on Thursday. Assalamualaikum and good day.